For today's lesson, we'll be discussing about classifying triangles. Polygons are classified based on the number of their sides, and a polygon with 3 sides is called a triangle. The word triangle comes from the Latin word triangulus, which means three-cornered. Ancient civilizations like the Egyptians used triangles in their iconic pyramids, showcasing the stability and strength of this shape. Naming a triangle. A triangle can be named using its 3 vertices. Take note that a polygon consists of vertices, which is this one. So this is your vertex A, vertex B, and vertex C. So the name of this triangle is triangle ABC. So again, a triangle can be named using its 3 vertices. In classifying triangle can be classified in different ways. We can classify them based on the measure of their sides or the measure of their angles. We can classify triangles based on how many sides have equal measures. So the first one that we have as a classification of a triangle based on its side is what we call equilateral triangle. An equilateral triangle is a triangle where all of its 3 sides have equal measures. This figure here that you see is an example of an equilateral triangle. So the tick marks indicates that the sides have equal measures. Note that equilateral triangles are also equiangular. This means that the measure of their angles are also the same. Next is an isosceles triangle. An isosceles triangle is a triangle where 2 of its sides have equal measures. This figure, as you can see here, is an example of an isosceles triangle. Note that the third side at the bottom has 2 tick marks. This indicates that the measure of its side is different from the measure of the other 2 sides. So these 2 sides here are equal in measurement, while the other one, this third side, are not equal with the 2 sides. So therefore, we call it isosceles triangle. Note that equilateral triangles are also isosceles triangles because they both have 2 sides that are the same length. But remember that for equilateral triangles, all 3 sides are equal. The third one is scalene triangle. Scalene triangle is a triangle where none of its sides have equal measures. So this figure here is an example of a scalene triangle. Note that the tick marks here indicate that their measures are all different. We can also classify a triangle based on the kind of angle that it has. But before that, take note of a property of the angles of a triangle. The sum of the measures of the interior angles of a triangle is 180 degrees. This means that if you add all the angles of a triangle, the sum will always be 180 degrees. This figure, as you can see here, is what we call an acute triangle. An acute triangle is a triangle with 3 acute angles. Note that all 3 angles of a triangle are acute angles. This means that the triangle is called an acute triangle. Next, right triangle. A triangle with 1 right angle. So this figure that you see here is an example of a right triangle. Note that this triangle has 1 right angle based on the square symbol on one of the angle, while the other 2 angles, this one and this one, are acute angles. This means that this figure or this polygon is called a right triangle. The last one is an obtuse triangle, a triangle with one obtuse angle. So take note that this figure here is an obtuse angle or has an obtuse angle, therefore it is called an obtuse triangle. So the other two here are acute angle, while the other one, which is this one, is an obtuse angle, so we call it an obtuse triangle. Here, here are some tips for you to be able to determine if a triangle is right, acute, or obtuse. Always look at its largest angle. If the largest angle is an obtuse angle, then the triangle is an obtuse triangle. If the largest angle is a right angle, then the triangle is right triangle. And if the largest angle is an acute angle, then the triangle is an acute triangle. Let us have some example. Classify the given triangle based on its sides and angles. In this given figure, in this given triangle, the side AB or line segment AB has a measurement of 7 cm, while side AC or line segment AC is 7 cm as well, while line segment BC or side BC has a measurement of 5 cm. We can observe that two sides, which is AB and AC, are equal since they both measure 7 cm. This means that we can say that this triangle ABC is what we call an isosceles triangle. By definition, when we say isosceles triangle, it's a triangle whose two sides are equal in measurement. So since side AB and side AC has a measurement of 7 cm, therefore this is an isosceles triangle. Next, let us check the angles of the triangle. We can observe that the angle of this one, or the angle A, the angle B, and the angle C are all acute angle. This means that this triangle ABC is an acute triangle. Next, let us classify the given triangle. So given here a figure, the side GH has a measurement of 3 cm, side HI is 4 cm, and side GI or line segment GI is 5 cm. We can observe that all the sides of the triangle are not equal in length. So this means that triangle GHI is an scalene triangle. By definition, when we say scalene triangle, it's a triangle who has no equal sides. Next, let us check the angles of the triangle. We can observe here that angle H has a square symbol. It means that it is a right angle. So if it is a right angle, we can say that this is a right triangle. So it's an scalene triangle according to side, and it's a right triangle according to angle. Next, angle ABC is an equilateral triangle. So if AB or side AB is 2 cm, find the measurement of the other two sides of the triangle. So based on the given triangle ABC is an equilateral triangle, and AB has a measurement of 2C. So if we will illustrate it, it will become like this. Step 2, determine the measurement of the line segment AC, which is this one, and the line segment BC, which is this one. Take note that triangle ABC is an equilateral triangle. So when we say equilateral triangle, it means that all sides are equal. So this means that AB or line segment AB is equal to line segment AC and also equal to line segment BC. Since AB is 2 centimeter, we can also say that AC is also 2 centimeter and BC is also 2 centimeter. So these are the measurement of the missing sides. Next, triangle MNP is an isosceles triangle with MN or side MN is equal to side MP. If side MN is equal to 7 centimeter and side NP is 4 centimeter, what is the measurement of side or line segment MP? So step 1, let us illustrate the figure. So as you can see, this is our triangle. Let us now put the measurement of each side. So side MN is 7 centimeter while side NP is 4 centimeter. So what we are looking for is the measurement of the line segment MP or side MP. Take note that this triangle is an isosceles triangle. So by definition, an isosceles triangle has two equal sides. So if side MN is equal to side MP, and if the measurement of side MN is 7 centimeter, therefore, the measurement of side MP is also 7 centimeter. So that is the measurement of the missing side. Next, the measures of two angles of a triangle are 45 degree and 55 degree. What is the measure of the third angle? So step 1, you need to draw the figure. So take note that this is our figure, and take note also that 45 degree and 55 degree are considered as acute angles. Step 2, identify facts or properties that can be used to solve the problem. And step 3, analyze and solve the problem. So we are going to solve for the measure of the third angle of the triangle. We have to recall that the sum of the measures of the angle of a triangle is equal to 180 degrees. So based on the given, we know that the measures of the two angles are 45 degree and 55 degree. So based on the property of triangles, we also know that the sum of the measures of the three angles is equal to 180 degrees. So if we will compute the missing angle, which is this one, let us denote it as letter N, since we do not know yet the value. So by equation, it will become 45 degree plus 55 degree plus N, which is our missing angle, is equal to 180 degree. Let us now add the measures of the two angles. So 45 degree plus 55 degree, that is 100 degree, plus N equals 180 degrees. So thus the measure of the third angle added to 100 should be 180 degree. So we can now solve for the missing angle by subtracting 100 degree from 180 degree. So it will become N equals 180 degree minus 100 degree. So therefore, N now, or the missing angle now, is 80 degrees. So this is now 80 degrees. And the last example, the measures of the two angles of a triangle are 127 degree and 33 degree. So what is the measure of the third angle? So again, step 1 is you have to draw the figure. Step 2, identify the facts or properties that can be used to solve the problem. And then step 3, analyze and solve the problem. So take note that one of the measurement of the angle is 127 degrees. So we can say that we are talking about an obtuse triangle. So this is now 127 degree, while the other angle is 33 degree, which is an acute angle. So take note that the sum of the interior angle of a triangle is 180 degree. So by equation, it will become 127 degree plus 33 degree plus N, which is our missing angle, is equal to 180 degree. So 127 degree plus 33 degree is 160 degree plus n equals 180 degrees. We can now solve for n. So n equals 180 degrees minus 160 degrees. So n now, or the third angle now, is 20 degrees. So this is now our missing angle.